These are notes number 12, the second notes for this week. You should already have your note paper set up from class, and the warm-up should be completed. Just make sure you have everything set up correctly. Pause if you need to, and we are going to move on to the notes. Okay, so today we're going to learn about two other ways to prove triangles congruent, SSS and SAS. Okay, I'm going to just show that whole page. So here's the first one. It's a postulate 16, angle, side, angle. Whoops, I think I wrote the wrong essential question. Okay, so angle, side, angle. Okay, so what this one says, and again, pause whenever you need to. If two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the two triangles are congruent. So it goes in order on a triangle, the angle, and then the side, and then the next angle. So kind of like as you're tracing it, one angle, side, angle. So just remember angle, side, angle. So this is the theorem or the postulate that's in the book, page 138. So it says if angle A is congruent to angle D, so let's go ahead and mark that. A is congruent to D. And then we have the side AC congruent to the side DF. So the side AC congruent to the side DF. And then the last one is another angle. We've got angle C is congruent to angle F. I'll do two arcs, and I'm also using different colors to show. So see how it goes angle, side, angle. It has to be the included side that joins or like touches the two angles. And then it has to match up with your congruent triangle. So then we've got, if that is true, then triangle ABC is congruent to triangle DEF. All right, and we'll do some examples in the book when we're done taking notes. So if you need to, pause. Otherwise, I'm going to move on to the next page. And remember that you need to have your 3 questions per side, per page of notes. So if I was a student, I would have to make sure I go back and put 1 question here, and maybe even 1 more here, depending on how much room it takes up. Okay, so here's our theorem, number 19. It is angle, angle, side theorem. And remember, a theorem must be proven, while a postulate is like a rule that we follow. So for theorem 19, angle, side, angle theorem, this is your angle, angle, side, AAS. If two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of another triangle, then the triangles are congruent. So I'm going to go through and mark the congruence. And on this one, you'll notice right away, angle A is congruent to angle D. The triangles aren't facing like the same way. You can tell that this triangle, it's almost like if it was rotated around and translated over. So moved over and rotated so that it looks like that. And then we've got angle B congruent to angle E. So 2 arcs for that. Oh, it's been flipped over too. So you can see if E is down there, it's been flipped. And then the side. Side AC is congruent to side DF. And then you can just check it. It would go, you can start from angle B, angle, angle, side, and then corresponding with E, angle, angle, side. So you want to try to visualize if you could flip that one over, like flip it back up, where E would match up with B, and then D would be where A is, and F would be where C is. Then you can tell that the two triangles are the same shape, but you'd have to do a reflection and a translation. And remember that when they're written like this, triangle ABC is congruent to triangle DEF, that the corresponding angles have to be in the same position. So, or not corresponding, the congruent angles. Well, they are corresponding too. So B and E are the congruent angles. B and E, you can tell, are marked the same. And then C and F. So C and F are the congruent and corresponding angles. Okay, so we're going to practice in the book now. We are going to be going to page 139, page 142, and page 144. And then I'll have a separate video for helping you with your ALEKS.com. Okay, so use your notes to help you. So look back at them so that you can try to figure out how to do these problems. So in the book, we are looking at number 1 and 2. This is page 139. And it says, name two triangles that are congruent by angle, side, angle. So we have to have an angle and then a side and then an angle. The side has to be included between the two angles. Okay, so look at them and try to see which ones even look like angle, side, angle. Just to show you real quick, like what that would look like would be an angle and a side and then an angle. And then it matches up with another triangle and it could point a different way. But on that triangle, you would have, and it can be all in different order, but an angle with one arc and then a side and then an angle with two arcs, and then they are congruent. So that's what we're looking for in number 1. So you should see that this middle triangle is wrong. It goes angle, angle, side. The side that's marked congruent is in the wrong spot, or maybe the angle is in the wrong spot. So that one's wrong. So I'm crossing it off. And so if I look at the other two triangles, I just have to write the letters in the correct order. So triangle, whatever the letters are, is congruent to that triangle. So I'm going to start with P, and then I'm going to go down to R, P, R, and then up to Q. That's how I'm going to name the first one. And then when I name the second triangle, I just have to be careful that I follow it like in the same order when I name it. So I'm starting with the angle with one arc. Look over here in this triangle. It would be angle V. And then I went to the angle that has two arcs and it's including the side that's congruent. So from V, should I go to X or should I go to W? So you should see, since I'm trying to match it up and be the same, V goes to W, and then from W I go to X. So I'm following the congruent parts. The single arc to the side to the double arc. Single arc to the side to the double arc, back to the other one. Okay, so that is angle, side, angle. All right, same thing on number 2. You're looking for angle, side, angle. I bet you can solve that one. So do exactly what I just did, and when you're done, I should see what triangle is congruent to which triangle. One of them isn't right, and then the two that are right, you have to name in the correct order. So look back at number 1 and try number 2. All right, now we're going to go to the next page, 142. So again, when you turn in your notes after this lesson, maybe you turn them in Friday or Thursday, make sure you include a picture that has this so I can check and see if you got it correct. Remember, naming it is super important that you have the corresponding letters in the same order. Okay, so page 142, I'm going to skip a little bit and we're going to try a proof. Remember, for proofs, you need to use your list. Okay, I got to put this up there. Okay, so look at the list on PowerSchool. I have my copy, so I can look at different properties, different theorems, all these different theorems right there. Okay, so whenever you're going to do a proof, make sure you look at the given, look at the diagram, make sure everything's marked that you know, and see what are you trying to prove. So our goal is to prove that triangle NQT is congruent to triangle SQR. So N to Q to T is congruent to SQR. SQR. So look at how the two triangles are related. It's like a rotation. It's like if you rotate one of the triangles around this point and you try to make the S go match up with the N, then the R would be where the T is, and that Q just stays where it is. Anyways, angle N is congruent to angle S, that's marked. Line L bisects TR at Q. So if TR is bisected, if you forgot what that means, we can look it up in our list. Definition of segment bisector means that it cuts it in the segment into two congruent parts. So the two segments would be congruent. That's what a segment bisector means. Okay, so I'm going to get going. So we've got the given, it's already filled in, and then we've got angle NQT is congruent to angle SQR. So NQT is right here. I'll mark it with two arcs, and then SQR. Go from S to Q to R. Think about, why are those two angles congruent? We have to give the reason. And the reason is on the list. It's right there. Vertical angles are congruent. Okay, so I'm going to go ahead and write that down. Vertical angles, I'm just going to use symbols. Vertical angles are congruent. Okay, and then moving on to the next one. This is your part that was up here. I remember reading it. That's why you want to make sure you read the given and look at the diagram. Line L bisects segment TR at Q. So segment TR is cut in half, bisected at Q. That's just given. But what follows that, we need to figure it out. Luckily, they give us a little hint. Definition of bisect. So let me look back at my list just to make sure I understand what that means. So I have second definition of segment bisector. So that means that the segment is cut in half, and I can mark two congruent segments. So TQ is congruent to RQ. I'm going to write it right here. TQ is congruent to RQ. Make sure you do that little segment symbol on the top. Let me see, it looks a little glary. Okay, there. Okay, so since that segment was bisected at point Q by line L, it cuts it in half. TQ is congruent to RQ. Okay, and it looks like we're done. We've got the triangles congruent. So let's see, why are they congruent? When we are proving triangles congruent, we have side, 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 angle, side. Did we just do angle, side, angle? And then angle, angle, side. That's what we just took notes on today. So it's one of those ones. Okay, so look at the two triangles. Is it angle, side, angle, or angle, angle, side? So if I start at the single arc and go in order, angle, angle, side. Same thing here, angle, angle, side. So it's by angle, angle, side. And that's all you have to write. Okay, pause if you need to, but I'm going to go to the next problem, which is on page 143. We're just going to look at this one real quick. There's a lot of space to answer this problem, but it doesn't take that much to explain it. All right, so it says our triangle PAR and SI are congruent. So they're saying that P is congruent to S, and then you go to A. So I'm going to go from P to A, following that order, and S to I. S to I. So that looks good so far. The one that's not marked to the single arc, the one that's not marked to the single arc, and then from A to R. So from A to R. Okay, and then the other side is the congruent side, and then from I to R over here. So what do you think? Are those congruent, and why? They only have one angle and one side marked. So as it is, without me doing anything, I would have to say no, they're not congruent. However, I do see something I can mark with a pen. So think about, what did I just mark over here? You can kind of see it still. What did I mark there that I could mark here also? So you should be thinking you can mark vertical angles congruent right there. Okay, and then that helps us because now it is angle, angle, side. Angle, angle, side. So I would say yes, since vertical angles are congruent, the triangles are congruent by angle, angle, side, AAS. If we didn't have vertical angles, then we would have to say no. But since I looked at it and I could tell, oh, we have vertical angles are congruent, we can mark it, and then it's angle, angle, side. All right, we're going to move on to our last few problems on the next page. Pause it if you need to. Okay, so page 144. Okay. So it says determine whether the triangles must be congruent. If so, name the postulate or theorem that justifies your answer. If not, explain why. So whenever you see two little triangles that share a side, always mark it congruent. The shared side is the same. So I would say MO is congruent to MO. If you don't remember, try to memorize this. It's by reflexive property. So it's by the reflexive property. MO segment is congruent to segment MO. Okay, so now that I marked that, if you look really carefully, you can see there's an angle M congruent to the other triangle's angle M, and then side, and then another angle. So it is angle, side, angle. And again, your choices would be for this section, angle, side, angle, or angle, angle, side. It's got to be one of those since it's in this section. Okay, so let's take a look at number 8. Again, I see a shared side, so I want to make sure I mark that. TS is congruent to, I think it's TS. So that side is congruent. Sometimes you mix the letters up. It might be backwards, but it's not a big deal. Okay, so all I've got is an angle and a side for one triangle for this one, and then an angle and a side for this one. You need to have 3, either angle, side, angle, or angle, angle, side. So what I'm noticing is, well, they do have parallel lines marked. So I'm going to trace, because tracing always helps you see things better. I'm going to trace my parallel lines, and then I notice they are cut by a transversal. And then I'm going to extend these parallel lines. And you should see we do have alternate interior angles. So I'm going to mark with 2 arcs, 1, 2, and then 1, 2. And I actually end up with angle, angle, side, angle, angle, side. Okay, so we had a shared side by reflexive property. Reflexive prop, whoa. I can't write like this. Okay, reflexive property. But then we also had alt interior angles congruent. So it was angle, angle, side. So the order of the angles and the side matters. Here it was angle, side, angle, and then here it's angle, angle, side. All right, and then we're just going to do the last 2 underneath. And just like everything in this class, basically, the more you practice, the more it's going to make sense. And if you have questions, make sure you ask them. Okay, so number 9, in triangle RST, which side is included between angle R and angle S? If you're not sure, draw a picture. So I'm like, I'd rather see the triangle. So if it's triangle RST, you could go RST or RST. It doesn't matter which way you go. You'll get the same answer either way. So in triangle RST, which side is included between angle R and S? So here is angle R, here is angle S. Which side is in between them? It's this side. So you could name it 2 ways. There's 2 correct answers. It could be RS or SR, but it doesn't involve T at all. So I don't care which way you name it, whichever way. Okay, so same thing on number 10. I think I'm going to let you guys try that one because it's really similar. In triangle NOM, side NO is included between which angles? So just like here, try to draw it. There's really no wrong way to draw it, NOM. You could start on any vertex of the triangle. It doesn't matter. NO is included between which angles? So you would say angle something and angle something else. That's how your answer should look. If you want, draw a picture, label it NOM, and see which two angles is segment NO in between. And that is it. Make sure you guys do your questions in your notes and your summary and finish your alex.com assignment number 12.